Students, let's start with the chapter 3 current electricity, right? In your class 10th, you have learned some basics, right? Let me to recapitulate the things, okay? Wherever you will be having doubt, I will be giving you a chance to ask, right? Student, first in current electricity, you should know what is strength of electric current, right? So what do you think, student? What is early classes you know? What is meant by electric current? The rate of flow of charge, right? Yes or no? So electric current means, student, the strength of, right? The strength of electric current, the strength of electric current is defined as, the strength of electric current is defined as the rate of flow of, is defined as the rate of flow of charge, rate of flow of charge through any cross section of a conductor, rate of flow of charge through any cross section of a conductor, rate of flow of charge through any cross section of a conductor. Right, students? Do you remember the formula? I is equal to Q by T. Yes or no? Of the conductor. Just a minute, not conduction of a conductor. You got, student? So simple electric current means rate of flow of charge, right? If anywhere it will be asking about instantaneous current, right? Instantaneous current. You will be learning a chapter. In class 11th, you have learned about limit, students. Learned or not? The instantaneous current, right? The instantaneous current is defined, the instantaneous current is defined by the equation, right? By the equation I is equal to limit delta t for very small time tends to 0, delta q change in charge by delta t. That in differentiation we write dq by dt. Do you remember or not? So this is the expression for instantaneous current, right? If anywhere we'll be dealing with average current, right? Anywhere we'll be dealing with average current, then that average current I is equal to Q by T, correct? That average current is I is equal to Q by T. In some cases, students, you can also see SI unit of current is ampere, you know, and CGS electromagnetic unit is ampere, right? So, student, if I'll be saying about ampere, what is meant by ampere? I is equal to Q by T. Let student, I will be taking Q is equal to 1 coulomb. Let 1 coulomb charge is flowing and T is equal to 1 second. Then only if 1 coulomb charge passes through a cross section of conductor per second, then the current is 1 ampere. Let in 1 second, 1 coulomb of charge is flowing. And student, 1 coulomb of charge means, you know, Q is equal to any. Do you remember? 6 to 5 into 10 to the power 16 electrons is known as 1 coulomb charge, right? So for defining 1 ampere, for defining ampere, you can write if 1 coulomb of charge, if 1 coulomb of charge passes through a cross section, 1 coulomb of charge passes through a cross section of the conductor, cross section of the conductor per second, then the current is 1 ampere. Then the current is 1 ampere. Then the current is 1 ampere. Right, student? That means you can define simply 1 ampere is equal to 1 coulomb per 1 second. There is no difficulties in this, right? 1 ampere is equal to 1 coulomb per 1 second, right? And student, current is a scalar quantity. We'll do how to make current into a vector. We take current density. We'll deal with that today. Current is a scalar quantity. Very theoretical part initially, right? Basically, in this chapter, you will be dealing with some basic laws of steady electric currents, and we'll analyze some electric circuits here in this chapter, right? Current is a scalar quantity. Student, let's know some applications, right? Give heading applications of electric current, means what problems you might get in daily test. You will get the questions on these concepts, right? Applications on electric current. Applications on electric current, right? Right, the applications on electric current. Okay, one by one, let's see. Student, sometimes what happens, uh, the current is not uniform. That means it's a time dependent, right? Current in a wire varies with time. It's not a steady current. Are you getting my point? That means if the current is varying with time, if the current is varying with time, if the current is varying with time t, then the charge flowing, then the charge flowing, then the charge flowing in a time interval, then the charge flowing in a time interval from t1 to t2, then you can, how you can do that? Q is I is equal to Q by T, means Q is equal to IT, students. Then Q is equal to I dt, small amount of current dt, limit T1 to T2. We'll take an example to understand that. This is the thing. Let's, student, for example, uh, one example let's take so that you can understand better. Current is given I is equal to 4 plus 2t, right? That current is a function of time that is given. I is in ampere and T is in second, right? Then total charge passed between the interval 2 second and 6 second, right? It is asking in the question the total charge passed, the total charge passed between interval t is equal to 2 second to t is equal to 3 second, right? So what to do that, students? Simply I is equal to 4 plus 2t. So to find total charge, q is equal to how much? So to do the question, q is equal to how much? You have to write, that is 4 plus 2t, 4 plus 2t, limit is from 2 to 6 dt, right? Students, see here, 4 is a constant. Are you getting? So you can integration 4 dt plus integration 2t dt 2 to 6. See here, 4 is coming out, integration of dt is t, right? 2 to 6 plus 2 is coming out, integration of t is t square by 2, correct? The limit is 2 to 6. Are you getting all? X to the power n plus 1 by n plus 1, yes or no? So that 4 into 6 is 6 minus 2 plus 2 cancel, then t square means 6 square minus 2 square, higher limit minus lower limit. Let's see how much coming. 4 into 6 minus 2, 4, 16 plus 36 minus 4, right? 6 6 is 36, 2 2 is 4. So how much it's coming, students? So here how much? 4 4 is 16, then 36 minus 4, that is 32. Then can you get 48 coulomb? Are you able to understand how to deal such type of questions, right? Got or not? This is first application of electric current. Let's go to a second application, right? So if n particles each having charge q passes through a given cross section, let there is a cross section, right? In this cross section, in every the time is given, right? So let's write the question. It will be in a numerical way. If n particles each having charge q, n particles each having charge q pass through a given cross-sectional area, pass through a given cross-sectional area, right? In time t, then the average current is, I is equal to, students, how many charges are flowing? N particles, each having how much charge? Nq. Then total charge is how much? Nq. Nq divided by T, right? Is that clear to all students? This is one type of question. Then number 3, you see. If a point charge Q, let's say there is a circular path, right? And this is the circle. This is the, right? About this point charge Q is revolving. Let there is a point charge, its magnitude is Q, right? And let the radius of the circle is R. और ये एक v speed पे revolve कर रहा है. So you can write here, if a point charge Q is revolving, in a circle of radius r with speed v, then its time period, Student, velocity is speed is equal to distance by time, student? Yes or no? Speed is equal to distance by time, correct? So speed is equal to, distance by time. So student, time will be how much? Distance by speed. So after moving one revolution, how much distance it will move? 2 pi r. 2 pi r divided by at what speed it was moving? V. So you can write T is equal to 2 pi r by V. Correct or not, students? Are you getting?
Yes, sir.
Okay. Next. This is one concept. This is number 3. Then number 4, another short concept I'm saying. You will face the questions on this. So it is revolving, right? It is revolving in a circular path. Then can I find the average current? So ये जो revolving charge है, अगर कोई भी charge revolve कर रहा है, so we can find the average charge, right? The average current associated with revolving charge, right? The average current associated with this revolving charge is, students, I is equal to Q by T, correct or not? And 1 by T is frequency, so can you write Q into F? Can you write or not? And student, do you remember omega is equal to 2 pi by T? Do you remember? Angular frequency, complete rotation, time taken to complete full cycle, angle theta. Omega is equal to theta by T. Angular frequency is equal to theta by T. So for one complete rotation, theta is equal to how much? 2 pi. And time taken to complete one cycle, that is time period. So 2 pi by T. So in place of omega is equal to 2 pi by t. Yes or no? So in place of, you can write here t is equal to how much? 2 pi by omega. And frequency is equal to how much? 1 by time period. So that is 1 by 2 pi by omega. That is equal to omega by 2 pi or not? So in place of frequency, you can write omega by 2 pi into q. Is that clear, students? Clear or not? And student, when a body moves in a circular path, do you remember what is the approximate relation I told about linear velocity and angular velocity? V is equal to radius times of angular velocity. Do you remember? And in place of omega, can you write V by R? Can you write or not? So here, where you have written I is equal to, after this omega by 2 pi into q was there. So in place of omega, you can write V q by 2 pi r. So student, if speed is given, radius is given, charge is given, then can you find current? Is that clear to all?
Yes, sir.
And here f is frequency of revolution. Here f is frequency of revolution. Frequency unit, what is the unit of frequency? Hertz, right? And what is omega, students? Angular frequency. What is omega? Angular frequency in theta by t, na? Radian per second. Clear or not? What is V? Linear velocity of the charge q, right? V is linear velocity of charge q. And r is the radius of the circular path. All will be given in the question. Just you have to find the current, right? Radius of the circular path. Got, students? Let there is a discharge tube, right? The previous experiments about electron and protons, let there is a discharge tube, right? Some electrons are going from left to right, and some are going from right to left, right? So in a question, you will get this. If in a discharge tube, right? If in a discharge tube, N1 protons, right, are moving, N1 protons are moving from left to right, from left to right in t seconds, and N2 electrons are moving in the same time, right? Are moving from right to left, from right to left, are moving from right to left. You can write here again. From right to left in t seconds. Then the current in any cross section of the discharge tube, then the current in any cross section, the current in any cross section of the discharge tube student, electrons going, protons going. Usually you think positive charge, negative charge, you will subtract both the charges. No, charge is, magnitude is same. Magnitude of charge is same, but the symbol is different. So simple, but you have to take the magnitude of charge electron. It may be electron, it may be proton, right? So it will be I is equal to number of electrons plus number of protons into charge, that is 1.6 into 10 to the minus 19 divided by time, right? And always students, which direction conventionally we have accepted the direction of current? Students, if in a conductor, conventionally we have accepted, right? This is a conductor. And in the conductor, student, if positive charges are flowing in this direction, current is flowing in this direction. If positive charge is flowing in this direction, then current is also in this direction. And electrons will be in this direction, right? Understood or not, students? Are you getting all? Students getting, na?
Yes, sir.
And you know, current is a scalar quantity, right? So current carrying conductor can define a vector which gives the direction. And then we introduced something that is current density. So let's know about a new thing, that is current density, right? Current density. Keep heading. Current density. Student, current density means कोई भी एक current carrying conductor, right? Current density at a point is defined as a vector having magnitude equal to current per unit area. Current per unit area. So you can write current density at a point, right? 1 minute. So you write current density, right? Current density at a point is defined as current density at a point is defined as a vector, having magnitude equal to current per unit area. Magnitude equal to current per unit area. Let's understand. Underline current per unit area. Current per unit area, right? That means, student, let's see if, right? So current density is a vector, right? So thus J, current density J is equal to I by A. And if you're referring vector, so let's give a n cap. What is n cap? N cap is the unit vector in the direction of flow of current, right? N cap is nothing where n vector is the unit vector. N cap is the unit vector in the direction of flow of current. In the direction of the flow of current. Right? Yes or no? Student, what is area vector? Do you remember? Already we have learned about area vector in Gauss law. Yes or no? It is always perpendicular to the plane and away from the plane. Getting, student? If in this conductor the current is flowing I, right? In this conductor the current is flowing I. Are you getting? The current is flowing I. So electrons are moving in this direction, opposite direction, right? And protons are moving in this direction, correct? है कि नहीं? So अगर मैं यहाँ पर अगर देखें, तो this is the direction of current density. And the small area you have taken dA, and the area vector is in this direction, in the same direction only. Are you getting all? But here let you do one thing in the conductor. I cut the conductor like this, right? I will cut the conductor like this. Are you getting, student? So how the conductor look like now, students? It will be like this or not? Are you getting, student? I have cut it like this. Yes or no? But actually the current is flowing in this direction. But the vector, area vector is in this direction. Let it is making angle theta. So here current density I is equal to, right? Current is a scalar, but current density is a vector. Area is a vector. You are multiplying two vector getting scalar. So scalar product you have to take, right? You have to take scalar product. Are you getting, students? You are able to see, students, now?
Yes, sir.
So I have cut the conductor. If it is a linear way, then here it is no problem, j dot d, right? But here this one you have taken as j vector and this is area vector inclined. So j dot a, you are multiplying two vectors. The result is a scalar. So that is equal to ja cos theta. Ja cos theta. Theta is the angle between j and a. Theta is the angle between j vector and a vector. Correct? And student, for variable, that current density is not linear, right? Keep in mind these things, it will come some places. For variable j, current I is equal to integration of j dot dA. Are you getting, student? Let area, it is dependent on area and it is varying like that. So this is all about current density. Student, you know, electric charges in a conductor, like for metals, it's due to free electrons, right? And when we're not giving any electric supply to the conductor or no battery is connected, so the electrons move randomly throughout the metal from one point to other point, right? Are you getting all my point? But suddenly when you are giving connecting to a battery means you are giving an electric field. And when charge particle will come in electric field, some force will be experienced or not. So they will start accelerating. Are you getting, students, my point? The free electrons get accelerated due to the electric field. और इलेक्ट्रिक फील्ड कहां से आया? जब आपने बैटरी लगवाया. और जब बैटरी आपने लगाया तो क्या हुआ? कुछ वेलोसिटी गेन हुआ, तो कुछ एनर्जी गेन हुआ. वेलोसिटी आया मतलब हाफ एम कर काइनेटिक एनर्जी आ गया. और जब ये इलेक्ट्रॉन्स मूव कर रहे हैं तो एक इलेक्ट्रॉन नहीं है ना, बहुत सारे इलेक्ट्रॉन है लैटिस में, लैटिस आयन में, राइट? तो वो इलेक्ट्रॉन एक दूसरे के साथ कोलाइड करेंगे. गेटिंग माय पॉइंट और नॉट? सो ये जो एनर्जी लॉस होता है कोलिजन के कारण, और ये एक्सीलरेशन जो इलेक्ट्रिक फील्ड में मिलता है, फाइनली क्या होता है? एक कोलिजन स्पीड को घटाता है, दूसरा फिर इलेक्ट्रिक फील्ड में एक एक्सीलरेशन भी मिल रहा है. मतलब दो चीज एट ए टाइम हो रहा है. और ये टोटल चीज को क्या कहते हैं? ड्रिफ्ट करना. एक्सीलरेट होते होते रुक जाना. गेटिंग माय पॉइंट और नॉट? उसी वर्ड को क्या कहते हैं? ड्रिफ्टिंग ऑफ इलेक्ट्रॉन्स. क्या कहते हैं? ड्रिफ्टिंग ऑफ इलेक्ट्रॉन्स. सो नेक्स्ट गिव हेडिंग drift velocity, the most important and very new part to you, that is drift velocity, right? Right, student? Drift velocity. Give heading and write drift velocity, right? Student, drift velocity kya hai? What is drift velocity? Right. Drift velocity is the average velocity. Keep on writing. Drift velocity. Drift velocity is the average velocity. Drift velocity is the average velocity acquired by free electrons inside a metal. Free electrons inside a metal by the application of an electric field. By the application of an electric field. By the application of an electric field, right? Which results in current. Which results in current. Correct. So drift velocity, that you just remember. Students, v velocity is equal to acceleration into time. Yes or no? velocity is equal to acceleration into time or not? Because acceleration is equal to velocity by time. Charged particles are getting accelerated, so velocity is equal to acceleration into time. And you know, जब electric field में charged particle आ जाता है तो F is equal to QE, and charged particle is having some mass ma. Both things I taught you in the previous lectures of the chapter 1 and 2. So acceleration is equal to QE by m. जो चार्ज पार्टिकल जा रहा है वहां पर हम Q कितना चार्ज, कितना इलेक्ट्रिक फील्ड और मास कितना है चार्ज पार्टिकल का, और हर एक एक कॉलिजन में कितना टाइम लगता है। टाउ को यहाँ पर क्या कहते हैं? रिलैक्सेशन टाइम, ड्रिफ्ट वेलोसिटी रिलेटेड टू रिलैक्सेशन टाइम। सो एक चीज आप यहाँ पर लिख सकते हो, सो यू कैन राइट हियर इन टर्म्स ऑफ, अगर हम ड्रिफ्ट वेलोसिटी की एक्सप्रेशन लिखें तो Vd is equal to, you can write drift velocity E charge into tau relaxation time divided by m into electric field in terms of applied electric field. drift velocity कैसे हमने क्यों लिखे समझ पे आया? एक्सेलरेशन इनटू टाइम कर दिए और एक्सेलरेशन की जगह पे QE by m डाल दिए, और जो टाइम हुआ वो एक कॉलिजन के बीच का टाइम हुआ। समझ पे आ रहा है कि नहीं स्टूडेंट्स? आर यू गेटिंग? Friends, another one thing, see, drift velocity, right? Drift velocity, just open the NCERT book and read the first 2 pages. We have covered up to that today. Drift velocity Vd is equal to, students, current density J by N into E, that is equal to, J means J by A into NE. Yes sir, you know J is current density, right? N is number of electrons, आप लिख सकते हो यहाँ पर N is number of free electrons, N is number of free electrons per unit volume, number of free electrons per unit volume, right? This is N. And what is E? Charge of electron. E is charge of electron, right students? एकदम आसान चीज। और ये हमने एक नॉर्मल इलेक्ट्रॉन लिया, एक इलेक्ट्रिक फील्ड लिया, मास लिया, रिलैक्सेशन टाइम लिया, दो कोलिजन के बीच में। तो यहाँ से एक दो पॉइंट जो हम कंक्लूड कर सकते हैं, नंबर 1 पे, स्टूडेंट, ड्रिफ्ट वेलोसिटी इज द ऑर्डर ऑफ 10 to the -4 मीटर पर सेकेंड, राइट? कोई आज पूछ रहा था क्लास में, राइट? द ड्रिफ्ट वेलोसिटी ऑफ electrons, right, is of the order of 10 to the power -4 मीटर पर सेकेंड, राइट? करेक्ट स्टूडेंट्स? और ये जो आपने फॉर्मूला लिखे ना, तो यहाँ से जो आपने लिखे Vd इज इक्वल टू J, अच्छा, एक चीज आपने यहाँ पर मार्क नहीं किए, यहाँ पर J फिर क्यों रहेगा, राइट? यू आर नॉट सीइंग एनीथिंग, तो दैट इज I by A। तो सिंपली जो एक बहुत इंपॉर्टेंट फॉर्मूला जो आपको आगे जाके मिलेगा, आप यहाँ पर जब क्रॉस मल्टीप्लिकेशन कर देंगे तो I इज इक्वल टू NeAVD लिख सकते हैं कि नहीं? NeAVD, कैन यू राइट और नॉट? ड्रिफ्ट वेलोसिटी इज ऑफ द इलेक्ट्रॉन्स इज द ऑर्डर ऑफ 10 to the -4। और स्टूडेंट दूसरा बात ये है कि जब इलेक्ट्रिक फील्ड ज्यादा होगा तो ड्रिफ्ट वेलोसिटी भी बढ़ जाएगा। ग्रेटर द इलेक्ट्रिक फील्ड, ग्रेटर द ड्रिफ्ट वेलोसिटी, राइट? और स्टूडेंट, डायरेक्शन ऑफ ड्रिफ्ट वेलोसिटी ऑफ इलेक्ट्रॉन्स इज इन अ मेटल इज अपोजिट टू दैट ऑफ द इलेक्ट्रिक फील्ड, राइट? हमेशा ये चीज याद रखो, डायरेक्शन ऑफ ड्रिफ्ट वेलोसिटी, direction of drift velocity in metal is opposite to that of electric field applied. Of electric field applied, ठीक है? Understood students?